Hello guys, you're welcome to my YouTube channel once again, and this week we are taking a look at how to solve the 1991 BECE objective test with respect or with reference to mathematics, making reference to mathematics. So in that respect, let's take a look at the questions 1 up to 40. We are done with 1990 past question, and then we are moving on to 1991. So without further ado, let's just jump into this. With question 1, this is what we have. There are two sets over here. If set P is equal to 1, 2, 3, 8, and 10, and then set Q is equal to 8, 1x, 3, and 2. If P is equal to Q, what is the value of x? So we are finding the value of x by comparing these two sets. So let's write down the sets. We have set P, and then we have set Q. Alright, so this is what we have for the two sets. And the question says, if set P is equal to set Q, what is the value of x? So taking a look at set P and then comparing it to set Q, this is what we have to do. First off, we have to arrange these particular members of set Q in the same order, all right, beginning from the least. So we have to arrange it in ascending order. So let's take set Q. Arrange the members of set Q in ascending order, beginning from 1. So we have 1, then we have 2 here, then we have 3, then we have 8, then we have x. If you compare this to that, all right, comparing this to this, there is this sort of equality between them. So we have arranged both in ascending order. So 1 here, 1 there, 2 here, 2 there, 3 here, 3 there, 8 here, 8 here, 10 here, then we have x. So the question says we should find the value of x. So if we compare 1, 1, 2, 2, 3, 3, 8, 8, then the last one is x, and over here it is 10. So it means that x over here is 10. Therefore, if set P is equal to set Q, then it means that the value of x over here will be equal to this, 10. All right, so we are done with question 1, and the answer is 10. Let's box on, take a look at question 2. It's the same question on set. So if set Y is equal to house, tree, and set V is equal to cat, house, and then tree, let's write them down. Set Y is equal to a house and a tree, and then we have set V, which is also equal to cat, house, and a tree. So taking a look at this, the question says, which of the following is true of set Y and V? Just looking at this, the only thing I can say about these two sets is that all the members that are found in set Y are also present in set V. So this is what it means. It means that set Y is a subset of set V, because all the members that are found in set Y are present in set V. So Y is a subset of set V. Let's go through the alternatives or the options that we were given. A says Y is equal to V, B says Y is a subset of V, C says V is a subset of Y, and then D says V is a member of Y. Taking a look at this, I said from the beginning that all the members in set Y are found in set V. So it means that set Y is a subset. So set Y is a subset of set V, because all the members in set Y are found in set V. And this is it. We are done for question 2. So Y is a subset of V. So with question 3, this is what we have. The following addition is in base 10. Find the missing addend. So base 10 addition is the usual addition that we do. You add, and then when you have a sum of 10, you write 0, and then you carry the remainder of 1 to the next place value. So it's the usual addition that we do. So let's write the question down. We have 2, 3, 4, 5. This is 2,345. And then we have 1, 0, 4. This is 1,045. And then we have these. So there's the question that we have, and we have 5, we have 1, we have 1, and then we have 0. We have been told to find the missing addend. The missing addend. So it means we have to add 2,345 to 1,045, and then to another number or value to give us a sum of 5,110. And we have been given the sum, but one of the addends is missing. So now we have to find this addend. Now, for us to be able to find the missing addend over here with asterisks, there is the need for us to add these to find the sum of this and that. After we have found the sum for this and that, then we subtract it from the sum that we have here, the final sum that we have here. So let's add this to that. So we have 2, 3, 4, 5. 1, 0, 4, 5. Let's add. Let's find the sum of these two. All right, so we find the sum for these two, and then we subtract the sum from this. So we add 5 to 5. We have 10. We write 0, remainder 1. 4 plus 4 is 8, plus 1 is 9. Two plus 1 gives us 3. So now that we have this, we have to subtract it from this particular one. So we have 5, 1, 1, 0. Then we have 3, 3, 9, 0. So let's find the difference. Let's find the difference over here. 0 minus 0 gives us 0. 1 minus 9 is not possible. We borrow 1 from here, and that is 10. So that 10 plus 1 will give us 11 over here. But we have only 0 left here. We borrow 1, and then we have 10. 10 plus 1 is 11. 11 minus 9 gives us 2. We have 0 here. We are subtracting 3 from 0. It's not possible. We borrow 1 from here. Then we have it to be 10. Then we have 4 remaining here. So it will be 10 minus 3. That gives us 7. And then 4 minus 3. That gives us 1. All right. Now we have the answer to number 3. And that gives us 1,720. So we are done for question 3. Let's box 1 and take a look at question 4. All right, so this is the question that we have for question 4. Given that, so let's write the question down. We have 2 squared multiplied by 3 squared multiplied by 7, and the product gives us 252. That's what we have here, 252. And the question says, find the least number that should be multiplied by 252 to make the product a perfect square. All right, so what this means is that they want to make the product of this particular multiplication sentence a perfect square. All right, the product, they want to make it a perfect square. And what does a perfect square mean? It means that that product that you are going to obtain, right, when you find its square root, it must give you a whole number. Do we get it? They want you to find another number that when you multiply it by this particular product, it will give you a product that when you find its square root, the answer will be a whole number. And that's basically what a perfect square means. So let's box on and take a look at that. They gave options over here. We have 2, 3, 6, 7. But to make it a perfect square, let's try multiplying it by the other numbers, such as 2, 3, 6, and 7. Let me begin with 3. All right. So it means that if we are going to get a perfect square, we need to multiply this by 3. All right. So 252 multiplied by 3. So we are adding by multiplying 3 in addition to this. Let's see what we are going to get. So we have 252 times 3 over here. We have 6. We have 15. We write 5, remainder 1. 3, 2 is 6 plus 1. The remainder 1. We have 7. 756. And what number multiplied by itself will give you 756? Or is square root of 756 going to give us a whole number? No, that wouldn't work. All right, find the square root of 756 and it won't give you a whole number. So that is not the correct number. That is supposed to be multiplied by the product to give us a perfect square. So let's try 7. Okay, 7. So it means that we have to write 2 exponent 2 times 3 exponent 2 multiply by 7 times 7 again to give us a perfect square. All right, so it's going to be 252 over here times 7. That is what it means. That is the meaning of this. All right, that is the meaning. This times this is equal to this times this. This times this is equal to the whole product of this. So this is it. Let's multiply 252 by 7. So 252 multiplied by 7. We have 14, 4, remainder 1. 7, 5 is 35 plus the remainder. So the question that we have here says we should write a particular number in standard form. And this is the decimal number that we are supposed to write in standard form. So we have 4687.02. And we are expressing this in standard form. We are told to express this in standard form. So to express a particular number or decimal value in a standard form, this is what we need to do. We need to express it in such a way that the whole number part will be between 0 and 10. That is from 1 up to 9. The whole number part of the decimal is supposed to be from 1 up to 9. So to make that happen, we will need to move the decimal point in between 4 and 6 so that the whole number part will be between 0 and 10, or will be from 1 to 9, to be within that particular range. So we move it to the left hand side once, twice, thrice, 3 times. And once you move it 3 times to the left, when you move it to the left, it means you are multiplying by 10. The number of times raised to the power, the number of times you move it to the left. So if I move it to the left once, it means I'm multiplying it by 10. I'm multiplying this whole value by 10 exponent 1. Twice means I'm multiplying this whole thing by 10 exponent 2. The third one means I'm multiplying this whole thing by 10 exponent 3. All right. So now it becomes 4.68702 times 10. We moved it 1, 2, 3 times. So exponent 3. And then we are done for this particular question as well. So question 5 has also been solved. The correct answer for question 5 is 4.68702 times 10 exponent 3. That is the correct answer for question 5. Now let's box on, take a look at question 6. There's what we have. We have 1, 1 is 001 base 2. And then we are converting this to a decimal numeral. So to convert base 2 value to a decimal numeral, this is how we go about this particular one. So we take 1, multiply it by 2. We take this, multiply it by 2. We take this, all of them multiply by 2, and then we raise it to a particular power, beginning from the right hand side to the left. The least power, we begin with the least power from the right hand side to the left. So we take 1, multiply it by 2. 1 multiplied by 2, then plus 1 multiplied by 2 again. This is the second one. Then plus, we have 0 multiplied by 2. The second 0 plus the second 0 multiplied by 2, that's the 2, plus this 1 multiplied by 2 again. All right, so we take the base that we have and then we start raising the base to its exponent beginning from 0. So this base will be exponent 0, this base will be exponent 1, this one will be 2, this one will be 3, and this one will be 4. Great. So once we have this, we will need to simplify each of them in the bracket, and then we find their sum for us to convert this in base 2 to decimal numeral, that is base 10. So this is what we do. We have 1 multiplied by 2 exponent 4 gives us 16. That is 2 times 2 times 2 times 2. 2 multiplying itself 4 times. So that gives us 16 plus 1 multiplied by 2 exponent 3 gives us 8. And then we have 0 multiplied by 2 exponent 2 gives us 4, plus 0 multiplied by 2 exponent 1 gives us 2, plus 1 multiplied by 2 exponent 0 gives us 1. Note that in indices, all right, it says that when you have any non-zero number that is raised to the power 0 or has an exponent of 0, the whole result will give you 1. All right, that's why over here we have 1. So if you have 10 exponent 0, it gives you 1. 100 exponent 0 gives you 1. That is what it means. That's what it means. So 1 multiplies 16, we have 16, plus 1 multiplies 8, we have 8. 0 multiplies 4, we have 0. All right, I nearly wrote 4. 0 multiplies 2, we have 0. And then 1 multiplies 1, we have 1. So let's find the sum of all these. 16 plus 8 gives us 24, plus 0 gives us the same 24, plus 0 gives us the same 24, 24 plus 1 gives us 25. Going forward, so if you have 11001 base 2, it is equal to 25. That's to the base 10. All right, so we are done with question 6, and the answer is 25. So let's box on, take a look at question 7. So it's a question on fractions. A boy spends 2 out of 7 of his pocket money on transport and 1 out of 5 on sweets. What fraction of his pocket money does he spend on transport and sweets? All right, so this is a word problem on fractions. So let's take a look at how we can solve this particular question. So if we are supposed to find the fraction of his pocket money he spends on transport and sweets, it means that we are supposed to find the sum of the fractions of money spent on both transport and sweets. So it means that you've got to write these things down. That's up there. So money spent on transport is equal to 2 out of 7, and then fraction of money spent on sweets, so money, though I have written money spent on, but we are talking about fraction of money spent on sweets. Because of the space that I have that I'm working with over here, there is the need for me to adjust, okay, so that you will see everything that is going on over here, so that you'll be able to learn everything as I explain. So the fraction of money spent on sweets is equal to 1 out of 5. So we have to find the sum of money spent on both transport and sweets. So sum of the fraction of money spent on both transport and sweets will be the fraction of money spent on transport, that is 2 out of 7, plus the fraction of money spent on sweets, which is 1 out of 5. All right, over here there are several ways to solve this particular question. All right, either you find the LCM or you use what we call equivalent fraction methods, all right, to find this. For time's sake, let's find the LCM. That's the usual one that we use. So the LCM of 7 and 5 will be 35. All right, they are both prime numbers. Usually when you're finding the LCM of two prime numbers, the only thing you do is just to multiply the denominators. I'm talking about only prime numbers. Stick to that, only prime numbers. So you multiply 7 by 5, then you have 35. That is the LCM. And I write the LCM, which is what? 35. So the LCM is 35. The LCM of 7 and 5 is 35. So 35 is here. 7 divides 35 5 times. You divide, you multiply. You divide, you multiply. 7 divides 35 5 times. 5 multiplies 2, you have 10. Bring the addition sign. 5 divides 35, you have 7. 7 multiplies 1, you have 7. Then going forward, 10 plus 7 gives us 17 out of the 35. So that's what we have over here. 17 out of 35. We have 17 out of 35. And that is the answer to question 7. So the sum of money, all right, the fraction of the sum of money spent on both transport and sweets is equal to 17 out of 35. So let's box on, take a look at question 8. So this is what question 8 says. it reads the product of three numbers is 1197. Two of the numbers are 3 and 19. Find the third number. So this is it. If you have three numbers multiplying all together, and then the product gives you 1197, and you are given two of those numbers, it means you have to find the third one. All right, there is the need for you to find the third one. That one is not known, so we use a variable to represent that particular missing value, and then we solve it. So let's box on to question 8 right now. So we have three numbers. We have 3, 19, and then a third number. That third number is not known. So all right, let A be the third number. All right, so A over here is the third number. So the third number is A. When all of these are multiplied, the product gives us 1197. So let's multiply all these three numbers, and then the answer will be equal to 1197. So we have 3 multiplying 19 multiplying A, and the product gives us 1197. That is it. So all these are numbers, but this is a variable. So let's multiply 3 by 19. We have 19 over here, multiply by 3. 3 9 is 27, 7 remainder 2. 3 1 is 3, plus 2 gives us 5. So we have 57. So 57 multiplied by A. This multiplies this is 57, then multiplied by A, which is equal to 1197. That's what we have. All right, so right from here, this is what we've got to do. Let's multiply this by this. We have 57A, which is equal to 1197. All right, let's rewrite the same thing again. 57A is equal to 1197. Now, to find the value of this A, let's divide here and here. To find A, you divide here by the coefficient of A, which is 57. So we divide here by 57. And go and divide it by that same 57. So this, we divide this, and then they will be gone. You will have only A standing. Then you have 1197 divided by 57. Let's search for a common factor that can divide this and that. All right. So let's begin by using the least number that we know can divide 57 and then 1197. So let's use 3. 3 divides 5, then you have 1. A single time, remember 2. The 2 comes here, you have 27. 3 divides 27, then you have 9. All right. 3 can divide 11 3 times. There will be a remainder of 2. Bring the 2 in front of the 9, you have 29. 3 will divide 29 9 times, because 3 9 is 27. So 3 will divide the 29 9 times. There will be a remainder of 2. Bring the 2 in front of the 7, you have 27. 3 divides 27, then you have it to be 9 times. So now we have what we have over here. Let me cancel this and bring it down. A is equal to 399 out of 19. Let's take a look at the number of times that 19 can divide 399. Is it possible that 19 can divide 399? Let's take a look at that. So we have 399 divided by 19. That's what we have here. All right. 21 multiplied by 19. We have 9 here, 18. 1 here, 2 here. Let's find the sum. 9, 9, 3. Boom. We have the answer. So 19 divides itself a single time, divides 399 21 times. 21 out of 1 gives us 21. All right. So the value of A is 21. Therefore, the third number over here, all right, is 21. Take note of that. The third number here is 21. Take note of that. So we are done with question 8. Let's box on, take a look at question 9. Find the GCF, that's the greatest common factor, or HCF, which is the highest common factor of 2 exponent 3 multiplied by 3 exponent 2 and 2 exponent 3 multiplied by 3 exponent 4. There's the question that we have. So we are finding the highest common factor or the greatest common factor for these two multiplication sentences. All right. So let's look at how best we can find that. Now, to find the factor for these two, we've got to search for the common factors, all right, from the multiplication sentence. So over here, we have 2 exponent 3. It's the same 2 exponent 3. So we have to take that, 2 exponent 3. Then multiply it by, let's take the 3's, all right. We have 3 exponent 2 and then 3 exponent 4. 3 exponent 2 is found here in 3 exponent 4 because 3 exponent 4 is bigger than 3 exponent 2. I believe you understand what I'm saying, because 3 exponent 2 will give us 9. 3 exponent 2 gives us 9, and then 3 exponent 4 gives us 81. All right, 3 exponent 4 will surely give us 81. So if 3 exponent 4 will give us 81, it means 3 exponent 4 is bigger than 3 exponent 2. So this is found here. 9 is a factor of 81. So it means 3 exponent 2 is also a factor of 3 exponent 4. I believe you understand the idea that I'm putting across. When this happens, it means that 3 exponent 2 is found here. It is also found here. So that is the common factor that we have to write here. So you write it down. And then we multiply these two, all right, to find the highest common factor for this and that. So let's multiply these two. 2 exponent 3 means 2 times 2 times 2. 2 multiplying itself 3 times, times 3 exponent 2 means 3 is multiplying itself 2 times. All right. So once we have this, let's find the product. 2 times 2 times 2 gives us 8. Let's write it down here. Multiply by 3, multiply by 3. 3 times 3 gives us 9. Let's take a look at the product of 8 and 9. 8 multiplies 9, then you have 72. So the highest common factor or the greatest common factor for this multiplication sentence and this is 72. So to find the highest common factor, just select the common factors in the multiplication sentence, because 2 exponent 3 is the same 2 exponent 3 here. So you take that one as part of the factors. Then 3 exponent 2 is also found here because this is bigger than this. 3 exponent 4 gives you 81. 3 exponent 2 gives you 9. So this is bigger than this. So this is a factor of this. So you bring that one to over here. You don't take the bigger one. You take the one that is the smallest. The smaller one can divide the bigger one over here. So you bring that one in over here as a factor. Then you multiply them out. You have 72. So we are done with question 9. Let's box on. Take a look at question 10 to 12. With question 10 to 12, we are using a particular diagram, all right, to find the answers to the questions given. So let's box on. Take a look at question 10 to 12. So this is the diagram that we have in the question, and the question says use the diagram below to answer questions 10 to 12. So question 10 says find the value of A. This is where we have A, all right? This is where A is found. But when you take a look at this particular triangle, this stroke and this stroke tell us that this particular triangle is an isosceles triangle. So with isosceles triangle, it has two sides. Its two sides being congruent. The length of the two sides are congruent. When this happens, it means that those lengths that lead to the base angles of those congruent lines also have the same angles. So if this length is equal to this length, it means the length to the base that forms the triangle to the baseline, this angle over here and this angle that will be found over here will be the same. So if here is 56 degrees, here will also be 56 what? Degrees. All right? Because the base angles are the same over here. Once the lengths of these sides are the same, it means the base angles are also the same. They are equal. So when this happens, it means that this is what we have to do. We write 56 here as well. Because the base angles over here are the same, we add A to 56, and that will give us 180 degrees because angle A over here and then this 56 degrees are adjacent angles on a straight line. Do we get it? They are angles on a straight line, adjacent angles on a straight line. When that happens, when you sum them up, their sum will be equal to 180. So to find A, it is A plus 56 degrees. That will be equal to 180 degrees. So to find the value of A, we'll go and subtract 56 degrees from 180 degrees. So we have A is equal to, then we have 180 degrees minus 56 degrees. You subtract 56 degrees from here, subtract 56 degrees from here, and then this one will give us 0. So we have only A left. Then let's find the difference between this. So A will be equal to, let's find the difference between 180 and 56. So 180 minus 56. This is where we have B. And if this is where we have B, it means that the interior angles of a triangle sum up to 180 degrees. That's the rule that we use. These are the interior angles of a triangle. This is a triangle, and these are the interior angles. So B plus 56 degrees plus 56 degrees should be equal to 180 degrees. So B plus 56 plus 56 degrees should be equal to 180 degrees. All right, so let's find the sum of 56 and this 56. So B plus 56 plus 56, let's see, we have 12. We write 2, remember 1 plus 5 is 6, 6 plus 5 is 11, so 112. So we have 112 degrees, and that is equal to 180 degrees. Same thing that we did over here, we do the same thing over here. So this is it. We have to go and subtract 112 from 180 degrees because it is adding over here. Subtract 112 from here, you have 0. Subtract 112 from here, so we have only B left here, which is equal to 180 degrees minus 112 degrees. Let's find the difference between 180 and 112. All right, so we have 180 and then 112. Let's find the difference. We borrow, we have 10 here, 7 is left here. So 10 minus 2 is 8, 7 minus 1 is 6. So we have it to be B is equal to 68 degrees. So that's the value of B over here. That's the value of B. Now let's box on, take a look at question 12. It says, what is the value of C? So this is where we have C. All right, this is where we have C. So there are several ways to solve this particular one with the C, but let's go by the same method, adjacent angles on a straight line. So 56 plus C plus 90 degrees should give us 180 degrees. Let's come down here, going forward, let's come down here to find the C. So it will be C plus 56 plus 19. So C plus 56 degrees plus 19 degrees is supposed to give us 180 degrees. When you sum up these three angles, the result should give you 180 degrees. So let's see, going forward from here, let's add 56 to 19. So 56 plus 19, and then we have 15 over here. We write 5, remember 1. We add the 1 over here. 1 plus 5 is 6, 6 plus 1 is 7, 75. So we have C plus 75 degrees. Both has given us 75 degrees, which is equal to 180 degrees that we have here. So going forward, we have to subtract 75 from 180 degrees. So C will be equal to 180 degrees minus 75 degrees. So let's subtract 75 from 180. So 180, 75. We borrow 1 from here to here, we have 10, then 7 is left here. Then 10 minus 5 gives us 5. 7 minus 7 gives us 0. Then we have 1 left here, 105. So this gives us 105 degrees. So that gives us 105 degrees, and this is how we go about the C as well. So we've solved for the value of A, B, and C. So we are done with using the diagram. Now let's box on to question 13 and take a look at the question. We are simplifying. The question says we should simplify this: 2ab squared multiplied by 3a squared b. So we are supposed to simplify this, and we are multiplying. A multiplies a squared. This a has a power of 1, but usually it's not written, and this one has a power of 2. Once they are multiplying, you add their powers. If this has a power of 1 and this has a power of 2, you take only one of the bases, which is a, and then you add their powers. 1 plus 2 gives you 3 over here, and then b squared multiplies b. This has a power of 2, a power of 1. They are multiplying. Take one of the base, which is b. They all have the same base, b. So we can add their powers. The power over here is 2, plus the power over here is 1. And then we have the sum of 2 and 1 giving us 3. So multiplying 2ab squared by 3a squared b gives us 6a cubed b cubed. That's what we have right now. So that is the answer to question 13. Now let's box on to question 14 and take a look at it. So question 14 says there is a relation, and this is it. We have it to be V is equal to U plus AT. So the question says we should find V. We should find the value of V when U. So when this U, when U is equal to 6, A is equal to 10, and then T is equal to 2. That's all we've got to do right now. So we are finding the value of V. So let's substitute the values that we've been given, all right, into the equation that we have, the relation that we have. V is equal to U is 6 plus A is 10 multiplied by T. T is 2. So V will be equal to 6 plus 10 multiplies 2, you have 20, and this gives us. So we are done with question 14. The answer is 26. Done. So let's box on, take a look at question 15 to 18. So the marks obtained by 10 children in a mental drill are 0, 1, 3, 3, 5, 7, 8, 9, 9, 9. Use this information to answer questions 15 to 18. So let's write the question down. We have 0, 1, 9, 9. That's what we have. So let's take a look at question 15. Question 15 says, what is the modal mark? Now, when we talk about a modal mark, it is the mark that appears often. The most frequently occurring mark over here becomes the modal mark. And from here, which of these marks appears frequently or appears the most often? We have 3 is 2 over here, and then 9 is 3 over here. So we have 3 9s, and then we have 2 3s. But when you compare the frequency of the mark 9, it is more than that of the 3. So 9 is the modal mark. So modal mark is 9. So that's the modal mark, 9. Now, the question says we should find the median mark. And this is what we have. Let's write the question down. All right, let's write the question down. There's the question. So let's solve question 16 right from here. Let's count the number of marks over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so the number of marks, which is n, is equal to 10. N represents the number of marks that we have. So to find the median mark, this is what we do. Find half of this 10. And this gives us 5. All right, so to find the median mark, usually you find half of the number of items or half of the number of marks that you have. Because this 10 that we found over here is even, you find half of it and that will give you 5. So you count the number of marks over here, you find the 5th mark and then the 6th mark. Because this one is 10, the number of marks over here is 10, you find the 5th one and the 6th one, you find their sum and then you divide it by 2. So we search for the 5th item. Let's count 1, 2, 3, 4, 5. So we have 5, and then the 6th item, that is this one. This is the 6th item. So find the sum of these two. That's 5 plus 7. When you are done, you find half of it. So we are finding half of 5 plus 7. That's what we are doing. So we have half. 5 plus 7 gives us 12. So half of 12 gives us 6. All right, it is 1 multiplied by 12, which is 12 divided by 2. 12 divided by 2 gives us 6. So the median mark is 6. That's what we have over here. The median mark is 6. All right, so we are done with question 16. Let's find the answer to question 17. We are calculating the mean mark. We are calculating the mean mark. To find the mean mark, to find the mean, you sum everything up divided by the number of items over here. All right, so add everything over here and divide it by counting the number of items. So we have 10 items, so add everything divided by 10. So it is 0 plus 1 plus 3 again plus 5 plus 7 plus 8 plus 9 plus 9 plus 9. 3 9s, and everything must be divided by 10. So everything divided by 10. Let's add. 0 plus 1 is 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 5, we have it to be 12. 12 plus 7 over here is 19. 19 plus 8 is 27. 27 plus 9 is 36. 36 plus 9 will give us 45. 45 plus 9 over here will give us 54. So we have it to be 54 divided by 10. That is what we have here. And this will give us 5.4. Or better still, if you use the long division method, 54. 10 divides 54 5 times. 5 times 10 gives us 50. Find the difference. The difference is 4. 10 can't divide 4. So bring a decimal point, add 0. 10 divides 40 4 times. That is 5.4. You multiply 40, then that's the difference you have. So it is 5.4. So the mean mark is 5.4. And we are done solving question 17. So let's box on and take a look at question 18. What is the probability that a child chosen at random scored 3 marks? So these are the marks over here. And if a child scored 3 marks, we have how many pupils scoring 3 marks? That is 2 pupils. All right, we have 2 of the 3 marks over here, meaning one individual scored 3, another individual or another pupil scored what? 3. So 2 pupils scored 3 marks. To find the probability that a student or a pupil or a child chosen at random scoring 3 marks will be 2 of these 3s. So 2 children scored 3 marks. So it will be 2. The probability will be 2 out of how many pupils or how many children? 2 out of how many children? That is 10 children. And finally, leaving this in the simplest form gives us 1 out of 5. 2 divides itself 1. 2 divides 10 5 times. And that is it. So with question 19, this is what we have. Boxing on to question 19, this is what we have. A trader received a commission of 12.5% on sales made in a month. His commission was 35,000 cedis. Find his total sales for the month. So if you receive a commission of 12.5%, let me write it down, the commission. We know the total sales is going to represent 100%. It represents 100% total sales. So total sales represent 100%. All right. So if the total sales represents 100% and the trader was giving the commission as 35,000 cedis, so it means that with the percentage of the commission, it is 12.5%. But in real money terms or in monetary terms, it is 35,000. So this is what it means. It means that the percentage of the commission is equal to the commission in monetary terms. That is the 35,000 cedis. So the 12.5 percent commission is equal to the monetary terms. That is the 35,000 Ghana cedis or 35,000 cedis given as the commission. So the 12.5% is equivalent to that, is equal to that. So we need to find the total sales for the month, and the total sales represents 100%. So if the total sales represents 100%, then what will be that total sale in real monetary terms or in monetary terms? What will be the total sales? For that, we don't know. So let's use a variable such as y to represent the total sales. So from here, we use proportion, all right? We cross multiply from here and then we find the value of y. So over here, 12.5 multiplies y, which will be equal to 100 multiplying 35,000 cedis. That is what we have right now. So let me rewrite this whole thing again. This 0.00 over here represents pesewas. There are no pesewas over there. There is no peswa, or there are no pesewas over there. So to solve this, this is how we go about it. There is the need for us to divide here by 12.5. Go and divide this same place too by 12.5. So this and that will be gone, and then we'll have only y standing over here. All right, so this becomes 100. If 100 multiplies 35,000, let's see what we are going to get. So 35,000 multiplying 100, 0, 0, 0, 0, 0. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 5, 3. Let's find the sum. We have 0 here, 0 here, 0 here, 0 here, 0 here, 5, and then 3. 1, 2, 3. 1, 2, 3. So we have 3,500,000 cedis over here. And this is going to be divided by 12.5. So let's change 12.5 to an improper fraction. This is a mixed fraction. So 12.5 will be equal to 12 multiplies 2. We have 24 plus 1. It is 25 out of these two. So y will be equal to 3,500,000 divided by 25 out of 2, and this gives us then 2 goes up, 25 comes down, times 2 goes up, 25 comes down. Division sign changes to multiplication. Find the reciprocal of 25 out of 2. So 2 will go up, 25 will come down. 2 is going to multiply this. So 2 multiplies 35, then we have 70. 2 will multiply this, 35, then we have 70. Because y will be equal to 2 multiplies 1, 2, 3, 4, 5, 5 zeros. 2 will multiply all these 5 zeros, and then we have 5 zeros. So 1, 2, 3, 4, 5. Then 2 will multiply 35 over here, then we have 70. So 1, 2, 3, 1, 2, 3. This becomes 7 million. 7 million cedis divided by 25. So let's divide this over here. 5 will divide 25 5 times. 5 will divide 7 a single time. There will be a remainder of 2. Bring the 2 in front of the 0. You have 20. 5 divides 20. You have 4. So you have divided the 70. You have 1, 2, 3, 4, 5 zeros. 1, 4, 1, 2, 3, 4, 5 zeros. So that is 1,400,000 then over 5. So y will be equal to, let's divide over here. 5 divides itself a single time, divides 14 2 times. There will be a remainder of 4. Bring the 4 in front of this 0 over here. You have 40. 5 divides 40 8 times. So we have divided these 3. We have 4 zeros left. So we have it to be 280,000.00. That's the persuasive. So if the trader receives 12.5% commission on the sales, then it means that the sales that he makes, the 100% sales the trader makes for that particular month will be 280,000 cedis, and that's what we have. So we are done solving question 19. Let's box one and then take a look at question 20. So with question 20, this is what we have. A map of a large town is drawn to the scale of 1:100,000. What is the distance in kilometers represented by a line segment 4 centimeters long on the map? So the scale is 1:100,000. That's what we have over here. So over here, this is the scale of the map. When you take every one, it gives you 100,000. All right. And even the conversion, 1 kilometer is equal to 100,000 centimeters. So if you are given a question such as finding the distance in kilometers represented by the line segment 4 centimeters long, then it means that what distance in kilometers? The distance in kilometers, that will give us 4 centimeters. The line segment was given to be 4 centimeters, and then this is the scale, so it will be 400,000 centimeters. All right. So when this happens, we cross multiply, and then we find the value of the x, which is the distance in kilometers. So this is how we go about it. X multiplies this, which will give us x multiplied by 100,000, which will be equal to 1 multiplied by 400,000. This gives us 100,000 x, and this gives us 400,000. To find the value of x, let's rewrite this whole thing over here again. Divide here by 100,000, divide here by 100,000, and then x will be equal to, so all these zeros will be gone, and then we have the value to be 4. So it will be 4 kilometers. That's what we have over here, to be 4 kilometers. So we are done with question 20. From question 21 to 40 continues on the next episode. I'm out of here. Please do well to subscribe to the channel to keep the channel growing. Thank you.